Hello everybody and welcome to 1.6 video part 2, rational equations. We left off on this last example where we got the answer of 7/4, and I talked about that you could either take this answer and plug it back into the original problem to see if this side equals this side, or you could even look into the extraneous solutions and make sure that the answer that you got was not one of the numbers that you can't have on the denominator. So one other thing I want to point out about this example before doing the last one is the reason why we can multiply everything by the LCD. Remember that when you are solving an equation, even a more simple equation like 2x plus 4 equals 7, if you wanted to, you can do the same things to both sides of the equation. So if I wanted to multiply this entire side by 2, I would have to multiply this entire side by 2 as well. That is why we're allowed to multiply by the LCD, because what you're really doing is multiplying this side by x plus 3x minus 2 and multiplying this side by x plus 3x minus 2. So whatever you do to one side, you do to the other. With the last example, the first thing I'd like you to do is pause the video briefly, and I would like you to write down what you think the least common denominator is. Remember, as soon as you see an x squared, please consider factoring. So please pause now. Okay, so what I did first was I factored x squared minus 9 to be x plus 3x minus 3. The second fraction had an x minus 3, and the third fraction had a 1. So I thought that the LCD had to be both x plus 3 and x minus 3 in order to continue the problem. So this was my LCD. The next thing we want to do is multiply all of these fractions by what it needs. But even before that, let's briefly talk about the extraneous solutions. Before we even start the problem, I noticed that the two numbers that I cannot have in my denominator would be 3 and negative 3. Because if I set this equal to 0, that would be negative 3. That equal to 0, that would be positive 3. So before I begin, I know that my answers cannot be negative 3 or 3. So with that, this first fraction already has both pieces of the LCD, so I'm good. This fraction needs the x plus 3, top and bottom, x plus 3. This fraction does not have either piece, so it needs both the x plus 3 and the x minus 3. So what we can do next, if you're interested, is we could simplify this a little bit before we multiply everything out. So we have 6 over x plus 3, x minus 3, minus 1 times x plus 3 over x plus 3, x minus 3 equals 1 times x plus 3, x minus 3 over x plus 3, x minus 3. So now that all three of these fractions have the same denominator, here, here, and here, I'm going to multiply everything by the LCD to get everything to cancel out. So I'm going to multiply by x plus 3, x minus 3. If I distributed that into every single term, all of these denominators would cross out with this green. So I'd be left with what is just in the numerator. So I'd be left with 6 minus 1 times x plus 3. Notice that I have parentheses around the x plus 3 because when you're subtracting, you're really distributing a negative 1, which applies to both numbers. Equals, I don't technically need the 1 here, so I'm just going to write x plus 3, x minus 3. Okay, so if I keep solving this, I'd have 6 minus 1x minus 3 equals, let's distribute or FOIL, x times x is x squared, x times negative 3 is negative 3x, 3 times x is 3x, 3 times negative 3 is negative 9. So on this side, it simplifies to be negative 1x, 6 minus 3, plus 3 equals x squared. These cancel out, minus 9. So if I keep solving this, I have an x squared in the problem, which means that I need to factor or solve a quadratic, which means it needs to be equal to 0. So I'm going to move the 1x to the other side, and at the same time, I'm going to subtract the 3 to the other side to get these both to cancel out. So I have 0 equals x squared plus 1x minus 12. Notice that I did not add these together because they are not like terms, but I did put it in standard form with the x squared first, x to the first second, and then the number. So if I continue to factor this, I know I have to because it's squared. Two numbers that multiply to be 12, negative 12, and add to be 1 is a positive 4 and a negative 3. So x, hypothetically, equals negative 4, and x equals positive 3. Now, here's why the extraneous solutions are so important. If you look back at the beginning, we said that x could not be negative 3 or 3, which means that this answer does not work. So my only answer is negative 4. And again, if you'd like to double check yourself there, take the negative 4, plug it back in anytime you see an x, and see if this side indeed does equal 1. All right, guys, we'll be practicing this a lot more in class tomorrow. Definitely we'll have some examples where you have to make sure to check extraneous solutions. Thanks for sticking with me.